Alright, so this is going to be section 2.3, and it's the title of the section is volume. I guess if I made a definition for volume, I'd say volume is the amount of three-dimensional space that an object occupies, I guess. And volume is measured in cubic units. For example, I guess you don't really have sugar cubes anymore, but a sugar cube that measures 1 centimeter on each side. Let me try to draw a picture. I don't think I can, but I will make an effort here. It's not going to be awesome. Used to be able to do these when I was a kid, but no longer can do these. Yeah, so that's a sugar cube, and it's supposed to be 1 centimeter by 1 centimeter by 1 centimeter. And this sugar cube that measures 1 centimeter on each side has a volume of 1 cubic centimeter. The name of this shape, when you have a three-dimensional object that has all straight line sides and each of the faces is a square, is called a cube. So this is a cube. The shape of a sugar cube is a cube, makes sense, and its volume is 1 cubic centimeter. And we might write that as 1 cm cubed. So when we're asked to find the volume of an object, our units have to be in cubic units. And essentially, when we're finding the volume of a three-dimensional object, we're trying to figure out how many cubes it will take to fill that object up. How many 1 by 1 by 1 cubes it'll take to fill that object up. And that's kind of where my write-up starts. The first problem that I have is not like a homework problem, but it gives me a figure, and this is a box, I guess, for lack of a better word. And if I look at the how the box is made up, this side right here of the box is a 3 centimeter by 5 centimeter rectangle. The top of my box is a 3 centimeter by 4 centimeter rectangle, and the bottom is, you can't see the bottom, but it's also that case. And this face right here is a 4 centimeter by 5 centimeter rectangle. So each of the sides of this box are composed of rectangles, and I cut those rectangles up into little squares. You can't really, well, I didn't really do this. I copied this from somewhere on the internet. But nevertheless, each of the sides is a rectangle. And so if I was naming this, I need to give somewheres in its name a rectangle. And we get a little bit fancy here. We probably call this a rectangular. And then a three-dimensional box is called a rectangular prism. So the shape of this is a, wow, the shape of this is a rectangular prism. And if I wanted to find its volume, I'd need to figure out how many boxes that are 1 by 1 by 1 it takes to fill this up, and that's what this drawing is supposed to show. So there are 1, 2, 3, 4, 5 layers to this, and if I look at the top layer, there's 4 boxes, and there's supposed to be another 4 boxes right there, and another 4 boxes right there. To fill up this top layer, if you counted the number of boxes, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 boxes that are 1 centimeter by 1 centimeter by 1 centimeter that make up the top layer of this rectangular prism. So the top layer of this rectangular prism has a volume of 12 cubic centimeters because it takes 12 boxes that are 1 cubic centimeter by 1 cubic centimeter by 1 cubic centimeter to fill it up. And then each layer, if you took that whole top layer off, you'd have another layer that has 12 boxes, and then you'd have another layer that has 12 boxes. And there are for this rectangular prism, there are 1, 2, 3, 4, 5 layers, each that take 12 cubic centimeters to fill it up. So the volume of this is 60 cubic centimeters, and usually instead of writing the word cubic something, I write an exponent of 3 to represent cubic units. And so this box was supposed to be made up of 60 individual 1 cubic centimeter cubes, and that's why its volume is 60 cubic centimeters. In this section, we're going to use formulas to find the volume. And the formula for the volume of a rectangular prism is volume equals the length times the width times the height. The length and the width refer to the dimensions of the top or the bottom of the box. And so my top is where I'm going to get the length and the width from. I could get the length and the width from my bottom. You'll notice that the top and the bottom are rectangles, and when I go to assign letters to the sides, for a rectangle, the sides are a length and the width, and generally the longer side is the length and the shorter side is the width. So for this problem, if I was using the formula to figure out its volume, the top's a rectangle, it's 4 by 3, I'd probably make the 4 the length, because it's the longer of the legs are the size of a rectangle. I'd make the 3 centimeters the width because it's the shorter length of the rectangular side. And then the height is the distance between the top and the bottom, and the distance between the top and the bottom is 5 centimeters. So if I was asked to use a formula to find the volume, I'd know that this is a rectangular prism. The volume formula for a rectangular prism is length times width times height. I'd multiply the numbers together. 4 times 3 is 12. 12 times 5 is 60. And I'd multiply centimeters times centimeters times centimeters. When you multiply centimeters times centimeters times centimeters, you get cubic centimeters. So even if this box wasn't cut up into 1 by 1 by 1 cubes, you can still find its volume if you have the volume formula that you need. So part of the difficulty in this section is just going to be looking at a shape and knowing what the shape is called so that you can pull out the right volume formula. And that's kind of what the next couple pages show. The next couple pages show 8 different shapes, and a cube, again, that's just a box where each side has the same length, And so this cube says we have a base that's S by S units and kind of a height that's S units. And the volume of a cube is you just multiply those three sides together. That says S cubed. We just did a rectangular prism, and it doesn't matter so much what you call the top and the bottom or the sides. To find the volume for a rectangular prism, you're just going to multiply the three different sides, and it doesn't really matter which side you call length, which side you call width, and which side you call height. A rectangular prism, or a box where the sides are made up of rectangles, will have three different lengths generally, and if you just multiply those three different lengths together, regardless of which length you call length, which you call width, and which you call height, that will still give you the volume. So when I did this problem here that wasn't numbered, if I would have said that the length is 5 centimeters and that the width is 4 centimeters and the height is 3 centimeters, looking at it kind of from a different perspective, I'd still get the same volume of 60 cubic centimeters. So when we're dealing with a rectangular prism, to find the volume, we're really just multiplying the three individual lengths, and it doesn't really matter which I call length, which I call width, and which I call height, which kind of this picture shows me, because I probably, if I was doing this, I would probably have called this a length, that a width, and that a height, but they're interchangeable. From this perspective, this is being considered the base, and then this is being considered the height. But it doesn't matter. When you're going, if you identify a shape as a rectangular prism, meaning each of the sides is either a rectangle or a square, you find the volume by multiplying the three individual sides. This sphere doesn't really look so sphery. It looks like a circle. On my computer, it looks more like it has a three-dimensional object. A sphere is something like a basketball. It's a three-dimensional ball. And the volume formula is 4/3 pi r cubed. I'll just move on from it, and when we need a sphere, I'll pull this back. A cylinder is like a Coke can, where the top and the bottom are circles. The distance between the top and the bottom is called the height, and the radius is the distance from the center of one of the tops of the bottoms to the side. And the volume for a cylinder or Coke can is pi r squared h. So cylinders kind of correspond to cones. Prisms kind of correspond to pyramids. A cone is, well, I guess you know what a cone is, but a cone comes to a point, as opposed to a cylinder that the top and the bottom are the same shape. For a cone, the base is a circle, and the two distances you need to find the volume of a cone are the radius, which is the distance between, on the bottom, the distance between the center and a side, and the height is the distance between the top and the bottom. Those are the two units that I need to find the volume of a cone. The volume of a cone is 1/3 pi r squared h. If you can't read it, I'm just worried that these things are written so small you can't read them. And then a pyramid, as opposed to a prism doesn't come to a point, a pyramid comes to a point. And this is a square pyramid because the base is a square that's s by s, and the height is the distance from the middle of the base to the top point is given an h, and the volume for a pyramid that has a square base is 1/3 s squared times h. So cones and prisms don't come to points. Cylinders and prisms don't come to points. Pyramids and cones come to points, and that's going to be different. That's going to be a big deal. So here are two special pyramids, and here's a special prism and a special pyramid that we're going to need in this section. And so I just made a special drawing for each one of these. This is called a triangular prism. It's a prism because it doesn't come to a point. And in a prism, generally at least one set of the sides are a rectangle. This is a triangular prism because the bases are triangles. And in order to get the volume of a prism, you have to multiply by the area of one of the triangles, and the area of any triangle is half the base times the height. So I have a base, a height. Half the base times the height is the area of the base. And then when you have a prism, you multiply the area of a cross section, or the area of the base, times the length, and the length is the distance between the bases. So the volume formula for a triangular prism, a prism where the bases or the cross sections are triangles, is half the base times the height. That's the area of the base times the length of it. Here's a pyramid that's not a square pyramid. So the base it's a rectangle, and so rectangles have an area of length times width. And in general, to get the volume of a cone, you multiply the area of the base times the distance between the base and the point, which is called the height. So the volume for this particular rectangular pyramid is going to be 1/3 the area of the base, which is length times the width, times the height. Alright, I don't know that I really needed to go through all those names and formulas, but I did. I don't even know how good it was. But let me jump into the homework now. I guess not quite the homework. Some sample problems before we get into the homework, because maybe there wasn't enough homework problems to actually do do everything nicely. So I'm going to do a few sample problems. This first sample, I want to find the volume of this three-dimensional object, and this is exactly a rectangular pyramid. It's a pyramid because it comes to a point, and the base of it's a rectangle. So the formula that I need is volume equals 1/3 times the length times the width times the height. The length and the width have to do with the dimensions of the rectangular base here. It doesn't matter if I call the length 8 or the length 7, but the length and the width are the 8 and the 7, and the height is the distance between the middle of the base and the top, and it's 6 inches. So when I do this, I'm going to say volume equals 1/3 times the length, which I'm going to call it 8 inches, but I could call it 7 inches, and then times the width, which I'm going to call 7 inches. The length and the width come from the rectangular base, and then the height is going to be 6 inches here. I don't really care to do these by hand this morning, so I'm going to do this on my calculator without the units. So on my calculator, I'm going to go 1 divided by 3, probably put it in the parentheses, and then times 8 times 7 times 6. That's going to give me 112, but of course, because it's volume, I need units. The units are inch times inch times inch. So I'm going to say the volume, I'll say V for volume, is 112 inches cubed. That's kind of all what the write-up says here. Move on to the next page and find another volume. And this is a triangular prism. It's a prism because it doesn't come to a point, and the bases are these triangles. And so to find the volume of a triangular prism, we have the formula volume equals half the base times the height times the length. The base and the height come from the triangle, and you can see them really clear here. The 15 is going to be the base, the 8 is going to be the height of the triangle. And so this first part, half the base, the height, the 1/2 of 15 centimeters times 8 centimeters, that's the area of one of the cross sections, or the area of the base. And then the length of this is going to be how far it is between the top and the bottom, and that's 12 centimeters. Again, I'm not really feeling motivated to do this by hand, so I'm going to do this on my calculator. So I'm going to go 1/2 in a parenthesis, so 1 divided by 2 times 15 times 8 times 12. I get 720. And then always when I'm finding volume, I need cubic units because I multiplied centimeters by centimeters times centimeters. I'm going to get cubic centimeters for my units. You might notice that this video looks different than any of the videos that I've shot, so far this semester. And it will probably be the only one that looks different. When I did section 2.3 like over Christmas break, I don't know that it was a horrible lecture, but I forgot to stop the video recording, and it recorded for 2 hours, and so the video was 2 hours long. I didn't know how to trim the video shorter, and some students wound up watching 2 hours of dead space. That I didn't feel so bad about, but right as I did the last problem in section 2.3, when I thought I shut the video off, I thought I messed up, and when I mess up, I usually redo the video, and I cussed at myself, and I never swear. I don't think I've ever swore in front of my parents, but there was a not nice word on the video, and I'm a student pointed that out to me, so I immediately deleted it. Well, I found out after we did the test over the material, and so I knew I wasn't going to keep that particular video up, and so we have a new video recording device that I'm using, and I think it makes videos a little bit better, other than it's really hard to make the pages straight, so they might wind up looking crooked all the time. Alright, so for this another example, this is a cone called a right circular cone, and its volume is 1/3 pi r squared h. Usually when there's a pi in the answer, I'm going to leave the pi as part of my volume. So in order to find the volume, I needed to know what shape it was. I need to have the volume formula, and then I need to know what the individual letters represent. And R has to do with the circular base, and it's the distance from the center of the circular base to the one of the sides. So the R is going to be 5.7 centimeters. And it's going to be 5.7 centimeters squared. And then the height's the distance from the center of the base to the point, and that's 12 centimeters. I'm not going to multiply by the pi. I'm going to multiply 1/3 times 5.7 squared times 12. Again, I'm being lazy this morning. So on my calculator, I'm going to go 1 divided by 3 times 5.7 squared times 12. I did all my times with parentheses, which is completely fine to do. You can use time signs as well. And this gives me 129.96. I'm going to math enter, and I could say it's really that. I'm troubled here because this number right there is not the same. My guess is that I did this right. Perplexed. Well, I see 129.96 or 3249 over 25, and then this right here has a units of centimeters squared. That has a unit of centimeters, and centimeters squared times centimeters gives me cubic centimeters. The volume for any object has to have cubic units. Let me do this again because, like I said, I'm disturbed that that number isn't the same as what I came up with today. I think this is just a mistake. Oh, I forgot the pi. Well, the volume, I didn't use the pi. I have to include the pi in my answer. Let me write these better. So I'm going to say the volume of this, because I didn't multiply by pi, I need to show that I still need to multiply by pi. It's 129.96 pi cubic centimeters, or 3249 over 25 pi cubic centimeters. Have the right volume formula. Volume is 1/3 pi r squared h. I'm going to do 1/3 times 5.7 squared times 12. I have no idea how you get 22 out of that. Let me make sure I haven't messed this up by going 1/3 and then times 5.7 squared times 12. You do get 129.96. Math, enter, enter. So this is the correct answer. I don't know what this number here, where that number came from, so pretend that isn't there. One more example, and then we'll get into the homework. And so for this example, it's a composite shape. This is made up of two shapes. The bottom here is kind of an upside down pyramid. I mean, it's upside down cone, should I say. So in order to find the volume, I'm going to have to do this as two separate shapes. The base, for lack of a better word, is a cone, and the top, it's like a half a basketball. It's like a basketball cut in half, and that's going to be a half a sphere. And so I'm going to need two volume formulas. For the top, I get a half a sphere, and the bottom is an entire cone. In general, the volume for a sphere is 4/3 pi r cubed. That would be for an entire sphere. I need to do half a sphere, so I need to take that volume formula and multiply it by a half. For a cone, the volume formula is 1/3 pi r squared h. So to do this figure's volume, I'm going to have to do the volume of the top separately from the volume of the bottom, and then I'm going to add the amounts together. So for the top, the r is 4, and so the volume of the top is going to be 1/2 times 4/3 times pi times 4 centimeters cubed. That I'm going to do on my calculator. I'm going to leave the pi just kind of hanging out. So to do this on my calculator without the units, I'm going to go 1 divided by 2 parentheses, and then 4 divided by 3. There's the 1/2 times 4/3, and then times 4 up arrow cubed, and math, enter, enter, because it doesn't say anything about decimals, so I'm going to go math, enter, enter. The volume of the top cone is 128 over 3. Haven't touched the pi, so it's going to have a pi in it. And volume always has cubic units. Since the lengths are centimeters, the volume is going to be in cubic centimeters. That's the volume of the top. Now I'm going to move on to the cone. And for the cone, it still has a radius of 4 centimeters. The bottom of the sphere and the top of the cone have the same circle. So in for the r, when I go to do the cone, I'm going to put a 4 centimeters, but I have to square it. And then the height of a cone is the distance between the center of the circular base to the point, and that's going to be. So I'm going to find its volume. I'm going to go parentheses 1 divided by 3, and then parentheses 4 squared, and then parentheses 10. Rather than using time signs, I'm using parentheses for my multiplication. And math, enter, enter. And so the volume of the cone is 160 over 3. I haven't dealt with the pi yet, so I leave the pi there. and then it's cubic centimeters. It's going to go centimeters cubed. The total volume for this shape, I have to add the two volumes together. So I'm going to do the volume of the sphere, or the top of this, which is 128 over 3 pi centimeters cubed, plus the volume of the cone that's on the base, which is 160 over 3 pi centimeters cubed. I'm going to leave the pi's. I'm going to add the 128 over 3 plus 160 over 3 to get the total volume of this composite shape. So now I need to go 128 divided by 3 plus 160 divided by 3. Oh, that's beautiful. So you get 96 for the number part. I need a pi, because I haven't multiplied by pi yet, and I need cubic centimeters. So the volume of this composite shape is 96 pi cubic centimeters. All right, with that as a warm-up, we should be ready to get into the section. My eyes don't work as like they used to, so for some of the problems I went through and wrote the units in because I flat out couldn't see them, and I went to my computer and just bumped them up. So hopefully I didn't write cruddy enough where it messes you up. So like most of the semester, we do evens and odds together. I'm going to do this even. You can do this odd. If you need to watch me do the even, watch me. If you don't, just jump into this. So for problem 1 and 2, these are rectangular prisms, and we did a rectangular prism or two already. The volume formula is length times width times height. I just pulled that from my sheet that I have off screen. And it doesn't matter what I call the length, the width, and the height. As long as I multiply the three individual lengths, I'm going to get a correct volume. So I'm going to say the base is this 2 by 3 rectangle, and the height is that. But I could, as long as I multiply the three lengths together, it doesn't matter the order that I multiply them together. So in a rectangle, once you've identified something as a rectangular prism, it should have three distinct lengths. Just multiply the three lengths together. It doesn't matter which one you call length, width, and height, and it will give you the volume. So I'm going to go 3 times 2 times 10, and I get 60. So my answer in number 2, the number is 60. I've multiplied centimeters times centimeters times centimeters, so I get 60 cubic centimeters. I have answers written for all your problems. Your problem 1 should have an answer of 194.4 cubic centimeters. Three and 4 are also rectangular prisms. They're just oriented a little bit differently. So I need to just multiply the three lengths together. And my lengths didn't have units attached to them. I said assume the units are in feet. So this is going to be a 12 feet by 6 feet by 5 feet rectangular prism. And its volume, I'm just going to multiply the three individual lengths. So 12 feet by 6 feet by 5 feet. Care to do that? 12 times 6 times 5. I get 360 cubic feet. For yours, you should have gotten 36 cubic feet. Six is a cylinder, technically a right circular cylinder, so I need that formula. So the volume is pi r squared h. Your cylinder's on its side, it hardly matters. The r comes from the circle side. So for mine, my top is going to have the r. It's the radius of a circle. For yours, your kind of side is going to have the r. So my r is going to be 2 centimeters. So I'm going to get volume equals pi times 2 centimeters squared. And then my height is going to be this unit, which is 4 centimeters. Technically, what I'm multiplying is volume equals pi times 2 centimeters times 2 centimeters times 4 centimeters, because squaring this means to multiply it by itself. So you see that my units are going to be cubic centimeters because I'm multiplying 3 different centimeters together. And I'm going to leave the pi in my answers when I'm not told to put in 3.14 for pi. And now I'm just going to multiply 4 times 2 times 2, and I think I get 16. So my answer for number 6 should be 16 pi cubic centimeters. I don't know if it helps or hurts for me to show the answers, but for number 5, your answer should be 192 pi centimeters cubed. 7 and 8 again are cylinders, and the volume for a cylinder, you don't have to have these memorized, I'll give them to you on the test. Volume was pi r squared h. My h is going to be this 15 centimeters. That distance is the same as this distance. So I'm going to write volume equals pi, and then I'm going to do 8 centimeters squared for the r squared, and then for my h it's going to be 15 centimeters. And then I'm just going to enter it like that, and in my answer I'm going to leave the pi. The units are going to be cubic centimeters, and then whatever 8 squared times 15 is going to go in for the rest of my answer. So 8 squared times 15, I get 960. That goes along with the pi cubic centimeters. For your problem 7, I didn't round. I wrote 4.608 feet. The instructions didn't say to round, but if you just whoa. I don't like your answer to number 7. For number 7, let me do your number 7. I would probably say, I'll change this. I'll say the volume equals pi. Oh, there's a trick here. This 3.2 feet is diameter. So in your problem, you have a diameter of 3.2 feet. 3.2 feet. That's not a radius. A radius is half a diameter. Divide that by 2 and you'll get 1.6 feet for your radius. And so I'm going to do 1.6 feet squared and then times 1.8 feet. So my volume, I'm going to have a pi and a feet cubed. There aren't any rounding instructions. And let me do this. 1.6 squared, I don't think I need the parentheses, times 1.8, and I get 4.608 pi feet cubed. Because it said to leave my answer with a pi, I'm leaving it with a pi, and my answer on this sheet was missing the pi. The students last semester didn't catch that. Alright, let's keep kind of plodding along. 9 and 10 are cones. Again, I don't have these formulas memorized. The volume for a cone is 1/3 pi r squared h. And again, I gave you the harder problem, which is unlike me. In my problem, it's easy. The h is the 8 centimeters, and the r is the 3 centimeters. In yours, you're given this length. That length is not the same as the height. So let me, instead of doing problem 9, instead of doing problem 10, I'm going to do your problem 9. Because in your problem, I didn't give you the radius, but I gave you the tools to get the radius, because look at what I have there is a right triangle. And so if I take this cross section and kind of blow it up, what I gave you for your cone is I gave you a right triangle that has a hypotenuse, or a C, of 10 meters, one side which I'll call a B, which is 8 meters, and your radius is kind of the A from the A squared plus B squared equal to C squared. So before I do your volume, I have to find the radius, and I'm going to use the formula A squared plus B squared equal to C squared, but I'm going to call this an R. I'm going to go r squared plus 8 squared equals 10 squared. I'm leaving the units off. This is going to have a unit in meters because it's just a physical length. So this is going to be r squared plus 64 equals 100. I'm going to minus 64 from both sides. I'm going to get r squared equal to 36. And then I'm going to square root both sides. I don't need the plus or minus because this is length. So for your problem 9, the radius is going to be 6. And the units I need on it are meters because all my lengths are in meters. So your problem 9 was a big step up in difficulty from my problem 10. So now I have multiple lengths, but the 8, the distance from the center of the base to the point, is the height, and this 6 meters is the radius. So your volume is going to be 1/3 pi from the formula, and then in for the r I'm going to put 6 meters squared, and in for the height I'm going to put 8 meters. And now I'm going to do everything except I'm not going to work with the pi, and I'm not going to work with the units. Units for volume are always cubic units. Since these are meters, I'll get cubic meters. Pi is going to stay. I'm going to multiply 6 squared times 8, and I get 288. So my answer for problem 9, or your answer for problem 9, the volume of this cone is 288 pi cubic centimeters. Whoa. 6, 8, 10, that's completely right. 1/3 times pi. The funny thing, not so funny thing is I have a different answer written for number 9 on the answer sheet. And I'll do this again in my head, but I don't think I have a mistake here. So that's a 6, 8, 10 triangle. 1/3. I forgot to do the 1/3. Ha ha ha. That is a wrong answer. I didn't go 1 divided by 3 times 6 squared times 8. Should be 96 pi. Sorry. Nicely that if I didn't have the answers written in front of me, I would have made a mistake there, because I ignored that 1/3. When I looked at my work and I said, oh gosh, I've got 96 pi. Why am I not getting 96 pi? So I started trying to do this in my head. So you should be checking all your answers. The nice thing about checking your answers, assuming my answers are right, then you know when you've messed up. And I completely forgot to multiply by that 1/3. So the answer should be 96 pi, and the units are meters cubed. For 11, the height, I didn't know if it was written big enough, so that 20 represents the height. It's supposed to be 20 centimeters. This 12 represents the radius, and again, I wasn't sure those were going to be readable, so I just wrote them bigger. So for yours, your height is 20, and it's supposed to be in centimeters. The radius is supposed to be 12 centimeters. And the volume for a cone is 1/3 pi r squared h. So I'm going to do my 12. You should probably just do your 11. So I'm going to go 1/3 times pi times 8 centimeters squared times 18. My volume answer is going to have both a pi and a centimeters cubed in the answer. And then I'm going to do parentheses 1 divided by 3 times 8 times 18 times 18, and I get 48 pi cubic centimeters. So you should do the same for your problem 11. And your problem 11, I think it should be 960 pi. I forgot the pi for number 11 in my answer and number 7. So I think it's 960 pi cubic centimeters. Yeah. 13 and 14 are square pyramids, and for a square pyramid, the volume formula is 1/3 s squared times h. It's a pyramid because it comes to a point and it has a non-circular base. It's a square pyramid because the bases are supposed to be squares, even though they look like a rectangle when I stretched them out. So for my volume, it says assume that the units are given in meters. So the S's are 4 meters, and this is a horrible picture because this doesn't have anything to do with the height. The height is the distance from the center of the base to the top point, which is 7, and this is a length that I don't need. Yours is better because it doesn't have a length that you don't need on it. So both of our heights are the 7, and mine are meters. And my base is 4 meters by 4 meters, yours is 5 by 5. So for my volume, I'm going to write 1/3 times 4 meters squared times my height of 7 meters. And mine says round to 2 decimals. Yours says leave in fraction form. Why I'm inconsistent there, I don't know. I'll give mine both in fraction form and rounded to 2 decimals just so you can kind of get a vibe for what your answer might look like as a decimal. So for 14, just following my instructions, I'd go 1 divided by 3 times 4 squared times 7. As a decimal, it's going to be 37.33 meters cubed. Hit math, enter, enter, and as a fraction, it's 112 over 3 meters cubed. I should write V equals because V will stand for volume. And yours, if you work it out, fine for number 13. I get 175 over 3. There's no pi's because there's no circle bases. I'm going to do this real quickly to make sure I'm okay with that. So 1 divided by 3 times 5 squared times 7. Math, enter, enter. Yours is 175 over 3. So 15 and 16 are more square pyramids. So I'm using the same formula. Volume equals 1/3 times R, 1/3 times S squared. I don't know why I just did that. Times the height is the formula. So for me, I'm going to do 1/3 times 10 centimeters squared times the height of 18 centimeters. You'll do something similar. And so on my calculator now, parentheses 1 divided by 3, parentheses 10 squared, parentheses 18, I get 600 for the number. And the units have to be cubic something, and since the lengths are in centimeters, it's going to be cubic centimeters. You have a square pyramid, same formula, different numbers, and your answer for problem 15 should be 48 cubic centimeters. '17 and 18 are pyramids, but they're rectangular pyramids. The volume formula for a rectangular pyramid is 1/3 length times width times height. It's basically the same formula, except the side squared turns into length times width, because side squared is the area formula for a square, length times width is the area formula for a rectangle. So mine has the numbers in. I'd probably call that a length, that a width, that a height. Turns out that it wouldn't matter in problem 17 if you shuffle the names around. As long as you multiply 1/3 by the 3 individual numbers, you'll get the correct volume. So I need to go 1/3 times 8 centimeters times 6 centimeters times 5 centimeters. So 1 divided by 3 times 8 times 6 times 5, and I get 80. And I need units. I'm going to put cubic centimeters in. For your problem 17, I get 112 cubic inches because the lengths are in inches. '19 is supposed to be a sphere, and the volume formula for a sphere is 4/3 pi r cubed. So to leave pi in my answer and a fraction in my answer. Both of us aren't given an r, we're given a d. The distance all the way across is the d. You have to divide that in half to get an r. So for your problem 19, your r is going to be 14 meters. And for mine, my r is going to be 3.5, because 7 divided by 2 is 3.5, or 7 over 2. So my diameter is 7 meters. If I divide that by 2, I get 7 halves meters for the r, and 7 halves is 3.5. It's easier for me to type in 3.5, and hopefully I can make that into a fraction. So I'm going to go volume is 4/3 times pi times 3.5 cubed. I should put up the meters in there. For my answer, I'm going to leave the pi in my answer because I'm told to leave a pi in my answer. My units are going to be cubic meters because volume is always cubic, whatever units you're starting with. And now I'm going to try to get this done by going 4 divided by 3 times 3.5 up arrow cubed, and then math, enter, enter. I get 343 over 6 pi meters cubed. Because it said leave my answer with a pi and as a fraction, that's the answer that we're looking for. Real quickly, I could do yours just so you want to see it. I'd go 4 divided by 3 times 14 up arrow 3, math, enter, enter. You get that lovely 10,976 over 3, and then pi, and then cubic centimeters, and that's what I wrote here for the answer to problem 19. 21 and 22 are spheres again, but they give us the r. Your r is 2 centimeters minus 14 centimeters. Again, I need the volume formula, which is 4/3 pi r cubed. I needed to know that this was a sphere. I needed to be able to pull off the formula, which will be given to you on the test. And I need to identify the right length. So I'm going to go 4/3 times pi times 14 centimeters cubed. My answer is going to have a pi and a cubic centimeters in, and whatever the multiplication comes out to be as a fraction. So I'm going to go 4 divided by 3 times 14 cubed, and math, enter, enter, and I get 10,976 over 3, exactly your answer from the last problem. It's exactly your answer from the last problem, because in your last problem, your radius was 14 meters minus 14 centimeters. The number is the same, the unit's different. All right, so give 21 a go. Getting closer to the end of this section. I'm going to do your 23 because it's harder than my 24. So in your 23, it's a composite shape. The top, I can't draw cones so well, is a cone, and the bottom is a half a sphere. It hardly looks like a sphere, but so that we have a top and a bottom, and the tricky part is that I don't know if I can draw this, but for the half a sphere on the bottom, its radius is 39 feet. So the distance, that distance that's marked is 39 feet. This distance that's not marked is also 39 feet. And so for the volume of this, the volume of a sphere is 4/3 pi r cubed, but I'm only doing a half a sphere, so I'm going to have to multiply that by 1/2. And for my bottom, I'm going to go 1/2 times 4/3 times pi times 39 feet cubed. That's going to give me the volume of the bottom of this. The top of this is a cone, and the cone, the distance from the center of the base to the point isn't 81 feet. 81 is the distance all the way from the top to the very bottom of this. This distance right here is the difference between the 81 feet from the very top to the bottom minus the 39 feet from the sphere part. So I'm going to have to subtract 81 minus 39 to get the height. And so for your cone, which has a volume formula of 1/3 pi r squared h, I had to do some work to figure out the h because it wasn't given to me, and I had to figure out I had to subtract to do that. So for the volume of the cone, I'm going to do 1/3 times pi, and then for r squared, it's going to be 39 feet squared, and then the height is going to be 42 feet. So just like I did in the beginning example a half hour or so ago, I'm going to do each volume separately and add them together. The instructions say write your answer in terms of a fraction with pi, and it gave you the hint that you needed to subtract to get the height of the cone. So let me figure out the cone part first because it's on top. I'm going to go 1 divided by 3 times 39 squared times 42. Oh wow. So that's 21,294 pi, because I haven't dealt with the pi, feet cubed. That's the volume of the cone on the top. And then for the bottom, half a sphere, I'm going to go 1/2 times 4/3 times 39 up arrow 3, and I get 39,546 pi feet cubed. I'm going to add the 39,546 plus the 21,294 and get 60,840, and then I'm going to attach the pi and the feet cubed. So the total volume is going to be the 21,294 pi feet cubed plus the 39,546 pi feet cubed. And when you add the 21,000 and the 39,000, you get 60,840, and then pi feet cubed for the total volume. And it's exactly what I got when I did problem 23 when I wrote my key. So I'm not going to do a 24. 24 is actually easier. I would have to do the sphere on top, and it's a half sphere, and then the base is a cylinder, and so I'd find the volume of each and add them together. Yours was harder, so I thought I'd do it. So your answer should be that, 60,840 pi feet cubed. So our problems 25 and 26 are supposed to be the same. Your drawing is easier to follow than mine. So my top is a cone, and my bottom is a cylinder. So I need to do the volume of the cone plus the volume of the cylinder. And that's exactly what your drawing has as well. Your top is a cone, and your volume is a really crunched cylinder, but it's a cylinder. For your cone, the height is 13 centimeters, the radius is 5 centimeters. For your cylindrical base, or for the cylinder, the radius is 5 centimeters, and the height is 2 centimeters. I'm going to need to do the same sort of thing for my cone and my height here in a second. So for my cone, the height is 4 centimeters. Yeah, I guess it is. And the radius is supposed to be 3 centimeters. This 3 centimeters is supposed to be the radius of the top and the bottom. So for my cone, it's going to have a height of 4 centimeters and a radius of 3 centimeters. For my cylinder, it's going to have a height of 8 centimeters and a radius of 3 centimeters. And we go to do our volumes. The volume for a cone is 1/3 pi r squared h, and for the cylinder, the volume is just pi r squared h. So I'm going to need to do my volumes separately. So I'm going to do first the cone. And my cone is going to have a volume of 1/3 times pi times 3 centimeters squared times 4 centimeters. I'm going to just do that real quickly. So I'm going to do clear 1/3, 1 divided by 3 times 3 squared times 4. I get 12 pi centimeters cubed. And then next I'm going to do the cylinder. Its volume is going to be pi times 3 centimeters squared times 8 centimeters, which is my height. I'm going to leave a pi and a centimeters cubed in my answer. I think I get 72, but I'm going to do this real quickly. Centimeters squared. I'm going to do 3 squared times 8 and get 72. I'm going to add these together, and to add these together, the pi and the centimeters cubed just kind of hang out. I just have to add the 72 and the 12, and I could do that without my calculator. So my total volume, my answer to problem 26, is the volume is 84 pi centimeters cubed. So you should do exactly the same thing for 25. Find the volume of the cone in terms of pi, find the volume of the cylinder in terms of pi. Your cone may have a fraction answer, and so your answer should probably be a fraction for 25. Well, it's not. It comes out nice, I guess. I'm surprised that it comes out so nice. I feel like I should do yours. So just because I'm worried about my key, let me do problem 25 with you. So the cone part, its volume is going to be 1/3 times pi times r squared, and r is 5 centimeters squared, times the height of 13 centimeters. So let me make sure I can do that. So that's going to be clear 1 divided by 3 times 5 squared times 13. Yeah, math, enter, enter. I get 325 over 3 pi centimeters cubed for the volume of the cone. And now I'm going to do the cylinder on the bottom. The volume is going to be pi r squared h, so it's going to be pi times 5 centimeters squared times the height of 2 centimeters. And that's going to be 5 squared times 2, which is 50. So it's going to be 50 pi centimeters cubed. So the total volume is going to be the 325 over 3 pi centimeters cubed plus 50 pi centimeters cubed. And to do this, I'm going to do 325 divided by 3 plus 50, math, enter, enter, and I get 475 over 3. And then pi in centimeters cubed for the answer to 25, which is not what I have written on my key. That's really disturbing. I taught this class for a semester. I was kind of hoping my students would find the mistakes so you wouldn't see them here. All right, for our 27 and 28, the top is a triangular prism. So the top has a volume of 1/2 the base times the height times the length. So first I'm going to do the volume of the top. I need to have some more distances. I need to copy these distances. This distance right here is 10. This distance right here is 8. And for the top, which is a pyramid, the volume is going to be it's a prism. It's a triangular prism. It's not a pyramid. It doesn't come to a point. So it's half the base times the height times the length. And for this, the triangular part of this, the height is 9, the base is 10, and all my units are supposed to be in feet. So the volume is going to be 1/2 the base, which is 10 feet, times the height, which is 9 feet, times the length, which is 8 feet. So the top of this is going to be 1/2 times 10 times 9 times 8 is 360 cubic feet. The bottom is just a rectangular prism, and the volume is the length times the width times the height. And when you have a rectangular prism, as long as you multiply the 3 individual lengths, it doesn't matter what you call length and width and height. So it's going to be 10 feet times 8 feet times 7 feet. And 10 times 8 times 7, it's 560 feet cubed. So the total volume for my answer, I need to take the 360 feet cubed and add the 560 feet cubed, 0, 12, I think you get 920 cubic feet. And that should be my answer to problem 28. Let me real quickly make sure I can do that adding without messing up. Yeah, I think it's spot on. Your triangle, the top is going to have a dimensions, the base, so for the top, the base is going to be 30, the height in feet is going to be 8 feet, and the length is going to be 50 feet. So those are the dimensions you need for the triangular prism on the top, and then the bottom is just 30 times 50 times, that's 12, I think. Looks like 12, and then the feet looks like it got trimmed. All right, so give 27 a go. Hopefully the answer is 24,000 cubic feet. We just have 2 more problems each, it looks like. All right, so your problem 29 is drawn better than my 30. I'm going to do 29 instead of 30. For the 29, the top is another triangular prism. So triangular prisms have volumes of 1/2 the base times the height times the length. And your bottom, again, is just a rectangular prism. So the volume is going to be length times width times height. And so for this top, this is the triangular base. That's the height. The base is 8 inches. So for the top, the triangular prism, the base is 8 inches. The height is 11 inches. And then the length is this length. It looks like it's 17 inches. So for the volume, I'm going to go 1/2 times 8 inches times 11 inches times 17 inches. I don't know how readable that is. This is 1/2 times 8 times 11 times 17. So parentheses, 1 divided by 2 times 8 times 11 times 17. And you get 748. It has to be cubic, and they're inches, so it's cubic inches. That's one number that I'm going to add to another. That's the volume of the top. The base is a lovely rectangular prism. I just multiply the 3 individual lengths. Volume is going to be 8 inches times 5 inches times 17 inches. So 8 times 5 times 17, and I get 680 cubic inches. And so the total volume, I need to add the 748 cubic inches plus the 680 cubic inches, and I get 1,428 cubic inches for the volume. So the answer to problem 29 is the volume equals 1,428 inches cubed. All right, so 30 I'll never do. If you work 30 out and you want to get an answer, visit me and I'll show you how to do it. Our 31 and 32 feel a lot alike, but I think it's probably worth my while doing the 31 instead of the 32. So if you want to do the 31 on your own, pause the video. If you want to watch me do it, watch me do it. On 31, you need to cut this into 2 rectangular prisms. And there's a couple ways we could cut it. I'm going to cut mine like this, and I'm going to find the volume of this rectangular prism on the top, and then this rectangular prism on the bottom. So this one, I need to cut it into 2 rectangular prisms. On mine over here, I probably would have cut it like into this rectangular prism and this rectangular prism if I had to, but I'm doing yours. So this top rectangular prism, I need to have 3 lengths, and I'm not sure if I have 3 lengths. I definitely don't, because this whole length across is the same as this. This whole length on this is 80, and from here to here is 60. So this little segment right here is an extra 20, because these 2 lengths together have to add up to the 80, because the 80 is the distance all the way across this top, and 60 of it was marked out. 20 is the other one that I need to do. So my top rectangular prism, the volume is the length times the width times the height, and these are in millimeters. So it's going to be multiply the 3 lengths, the 20, the 40, and now I have to get another length. And note, I have to double borrow. These 2 lengths are going to be the same right here. So this is a 10 millimeters, makes that length a 10 millimeters. So I was missing a lot of lengths on this one. It probably was a bad way to cut it, but that and that are the same, and similarly that and that are the same. And so that's going to be 20 by 10 by 40. So the top is 20 millimeters, the one in pink, times 10 millimeters times 40 millimeters. That's going to give me a volume of 20 times 10 times 40 of 8,000 millimeters cubed. The bottom in blue, I hope, is easier. Oh gosh, it's not so easy. I don't know if I cut this the best way, but I cut it the way I cut it, so I have to deal with it. So 2 of the lengths are easy for the bottom, the 80 and the 10. This distance right here is not so easy. The whole length from top to bottom is 60, and this distance right here is the same as that distance, which is 40. So if the whole length from top to bottom is 60 and that part's 40, the difference between 60 and 40, which is 20, is that little length. So the bottom of this, the bottom rectangular prism, its 3 unique lengths are 80, 20, and 10. So for the bottom, I don't really like this problem. It's 20 millimeters times 80 millimeters times 10 millimeters. These cuts are a lot harder. I couldn't imagine doing this on a test, but it's here, so we're doing it. And my bottom, it looks bigger, and it has a volume of 16,000 cubic millimeters. So my total volume is going to be the 8,000 millimeters cubed plus the 16,000 millimeters cubed. And when you add those together, you get 24,000. Can't see it. And then I have an extra 0. Obviously I'm ready to be done. So you get 24,000 millimeters cubed for the total volume. That would be the answer to 31. Alright, so that's the end of this section, and that's probably kind of the end of the geometry part of this chapter. This chapter 2 is kind of a bunch of different topics, and I'll just stop the video now.